Okay, so this video is going to be about enzyme kinetics. What are enzyme kinetics? They are the study of the rates of enzyme-catalyzed reactions. So let's go into the variables of the reaction. So rate is designated as V, okay, because it's going to stand for velocity of the reaction. And so K is going to be designated as the rate constant. So if you have a reactant and then you have a product right here, the rate constant is going to be K. So you can write this as rate equals V equals little k multiplied by the concentration of A. So the units of this K is going to be S to the negative 1. So let's talk about that, right? So we have, let's say, another reaction which is 2A, and then the rate constant is K, and then you have P. So you're going to write that as V equals K times A squared because there's two A's. Over here you have A plus B and then the rate constant, and then it turns into a product, right? So once again you're going to write V, which is going to stand for the rate, is equal to K times A times B because there's two different reactants. So in this case the units are going to be S to the negative 1, and over here the units are going to be over here the units are going to be S to the negative 1, and over here it's going to be M negative 1 and then S negative 1. So I'll talk about why that is. So for example, right here V equals K times A, well, that's a first order reaction, and so the end result velocity will always be in moles over seconds because that's the amount of reactant over unit of time. And so K, we designate it as 1 over S because it helps get to this unit, M over S. So it's going to be 1 over S times the molar concentration, right? Over here we have this reaction, right? So V equals Ka squared. And so what K will always equal something that will cancel out everything to make moles over seconds. So this has to be able to cancel out this to help make moles over seconds. So since one concentration of something is moles, since it's squared, it's going to be moles times moles, right? So the K has to equal 1 over ms, so one of the m's can cancel, and then it would turn into m over s. And that's why the K will adapt to whatever the reactant is to form moles over S on the left side. So in the next video, I'll talk about the Michaelis-Menten model, and I hope that helped, and thanks for watching.